DART, NASA's test to stop an asteroid from hitting Earth. What steps should we take if a perilous asteroid is headed towards Earth? Various deflection techniques exist, from dramatic methods like a nuclear blast to more subtle approaches such as utilizing a heavy spacecraft's gravity to redirect the asteroid. Between all the options lies the kinetic impactor technique. Here's a simple concept. One way to potentially alter an asteroid's direction toward Earth is by intentionally crashing one or more spacecraft into it at a high velocity. This method is especially effective when implemented well ahead of time, as minor influences can accumulate into significant transformations. In a groundbreaking space mission, DART, also known as NASA's Double Asteroid Redirection Test, became the pioneer in testing asteroid deflection techniques. In November 2021, DART embarked on its journey and reached the near-Earth asteroid Didymos in September 2022. On a fateful day, September 26, a spacecraft deliberately decided to crash into the asteroid's small moon, Dimorphos. After the crash, Dimorphos now takes 33 minutes less to orbit Didymos, demonstrating the success of the kinetic impactor technique. The main goal of DART is to showcase how an asteroid's path can be altered by employing a kinetic impactor method. The plan is to change the path of an asteroid by impacting it with spacecraft, either by increasing or decreasing its speed, to divert it from a potential collision with Earth. DART is a fascinating mission ahead as it sets its sights on a binary asteroid system. This system is home to two celestial bodies, the larger Didymos A and its smaller companion known as Didymos B or Dimorphos. This asteroid system's binary nature offers a unique chance to test the kinetic impactor technique. Scientists can witness the impact's effects on the smaller asteroid's orbit around the larger one. Crafted with a focus on efficiency and purpose, the DART spacecraft is a compact and straightforward vehicle tailored for its unique mission. It is well prepared with a propulsion system for navigating through space and a guidance system for accurately aiming at the asteroid. On board, DART is equipped with a camera and various instruments to study and understand the impact's consequences. The DART's kinetic impactor operates based on the concept of transferring momentum. At high speed, the spacecraft is set to approach Didymos B and intentionally collide with it. Although the spacecraft does not contain explosives, the impact will create enough kinetic energy to alter the asteroid's velocity. Scientists can evaluate the effectiveness of the kinetic impactor technique for asteroid deflection by carefully measuring the change in the asteroid's orbit. Aside from the impact event, DART will also study the consequences of the collision by utilizing its onboard instruments and remote sensing techniques. Ground-based observatories and telescopes will closely watch the asteroid both before and after the impact to collect more data. Scientists delve into the impact and effects to enhance their comprehension of asteroid dynamics and the potential success of different asteroid deflection methods. The DART mission embarks on a journey filled with collaboration from international partners such as the European Space Agency. Following the impact, ESA's Hera mission is set to launch after DART. It aims to offer more observations and measurements of the asteroid system. Working together on this project boosts the scientific significance of the mission and adds to worldwide initiatives in planetary defense. DART plays a crucial role in NASA's mission to identify, monitor, and understand near-Earth objects that may endanger our planet. Didymos B is not considered a threat, but the DART mission's a way to test out technologies and strategies that could help prevent asteroid impacts in the future. NASA's DART mission is crucial to the agency's ongoing work to evaluate and reduce the threat from near-Earth objects. Through a deep dive into the orbital dynamics and physical characteristics of asteroids such as Didymos, scientists gain valuable insights into the potential threats that could pose and that they can devise successful strategies to reduce those dangers. DART's crucial in providing essential data for this continuous risk evaluation process. Didymos and Dimorphos were the perfect candidates for DART's mission. Despite their small size, Didymos at 780 meters across and Dimorphos at 160 meters across pass in front of each other when viewed from Earth. When optical ground-based telescopes gaze upon the celestial bodies, they perceive them as a solitary gleam that wavers in luminosity as Dimorphos orbits around Didymos. The pattern of these fluctuations is anticipated to have shifted following the impact of DART. Moreover, Didymos and Dimorphos always need to get closer to Earth so that DART can accidentally redirect them towards our planet. 2 years after the spectacular fireworks display by DART at Dimorphos, the European Space Agency is gearing up to embark on a new mission named Hera. This mission aims to delve deeper into the study of Didymos and Dimorphos, and this will enable scientists to delve into DART's impact crater and grasp the complete impact of the mission. The DART project incurred a hefty price tag of $324.5 million. They poured $308 million into spacecraft development and $68.8 million into launch services, and anticipate spending $16.5 million on operations and data analysis. Once upon a time, before it collided with Dimorphos, DART was just a tiny spacecraft. The spacecraft's core was a small box measuring just a meter wide on all sides, but with the addition of 2 roll-out solar arrays that expanded to about 12 meters in width. The electric propulsion system of DART produced a stream of charged ions to provide a smooth and steady thrust. In November 2021, DART was launched on a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California. Once upon a time, the spacecraft circled Earth several times, utilizing its electric thruster to build up enough speed to break free from orbit. It journeyed onwards to Didymos, perhaps gliding by another asteroid known as 2001 CB21 along the path. Within DART was a lone science instrument known as Draco, a high-resolution camera that served a dual purpose for scientific observations and navigation. A camera like the one on NASA's New Horizons spacecraft inspired this. On September 11th, a CubeSat built by the Italian Space Agency was deployed by DART to observe the impact. 4 hours before impact, the main spacecraft was too distant from Earth for flight controllers to manage in real time, prompting it to switch to an autonomous navigation mode. Thanks to images from Draco, the spacecraft's computer could distinguish between Didymos and Dimorphos and navigate towards the latter. And just like that, the tale came to an end. On a fateful day, September 26, DART collided with Dimorphos, hurtling through space at a speed of 6.6 kilometers per second. The impact altered Dimorphos' orbital period around Didymos from 11.9 to 11.8 hours, a mere difference of 4.2 minutes. Dimorphos will be pulled slightly closer to Didymos. Before embarking on the DART mission, a thorough risk evaluation and impact modeling are carried out to assess the potential outcomes of an asteroid collision with Earth. Scientists carefully examine various factors like the size, speed, and composition of the asteroid. They also consider the potential impact of location and the effects on the Earth's surface. These assessments are crucial for prioritizing mitigation efforts and guiding decision-making in the face of an actual asteroid threat. DART is like a pioneer, showcasing improving asteroid deflection techniques. Though through the real-life tests on an actual asteroid, DART offers significant data and understanding about the effectiveness of the kinetic impactor approach. The mission validates computer models and simulations utilized in forecasting the results of asteroid deflection endeavors, thereby improving our capacity to evaluate and address potential asteroid hazards. Accurately guiding a spacecraft to collide with an asteroid demands sophisticated navigation and targeting skills. DART uses clever algorithms and onboard sensors to guide the spacecraft to its destination with remarkable accuracy skillfully. Mastering these navigation techniques is crucial to guiding the spacecraft toward the intended impact trajectory and enhancing the efficiency of the kinetic impactor method. The DART mission is a crucial milestone in humanity's ongoing mission to protect our planet from the danger of asteroid impacts. Having boldly journeyed into space and intentionally colliding with Dimorphos, DART has demonstrated the kinetic impactor technique's effectiveness and revealed the way ahead for asteroid deflection strategies. We strengthen our preparedness to face potential asteroid threats by examining the data collected from this momentous mission and exploring the intricacies of near-Earth objects. With DART at the forefront, we are expanding our scientific knowledge and enhancing our ability to safeguard Earth from cosmic threats. Looking ahead, the wisdom gained from DART will always steer us as we drive and strive to protect our planet and guarantee future generations' well-being.